So this is class engineering, mathematics 1. So if you are in the wrong class, then maybe it's a good time to leave the classroom. So there are 3 exchange students at the end of the list. Let me just check. Basley Holly. Okay. Cronson Brewagers. All right, good. Legrand, everyone Larry. Bien. So I'll just put it in the here. During the break time, whether your name is there or not. So if you're not, then probably you have to check with the department office at 4th floor. I think most of all will be interested in grade policy, right? Actually, I do have only one policy, that is for the A+. How do you get an A+? You should be top 10%. Very simple. So, I mean, if you have 99 students, probably 10 students will get an A+. And other grade, this is supposed to be English class, so it's not very strict, so I'm usually quite generous. I mean, it depends on person too, right? Some people still don't think I'm not very generous, but I'm trying to be generous. And about 60% from quiz, 1 hour or 2 hour quiz, 40% final exam. So how many times did we take a quiz last time? 3 times, right? So normally, during the semester, we take about 3 quizzes. Nominally 3 quizzes. And 1 final. So final covers the whole thing. The quiz covers a partial from the beginning to the end of the last class just before the quiz. And I don't like students memorize the formulas, so I allow you bring cheating sheet. For the quiz and finals, you can depending on 1 hour quiz, you can bring 1 page cheating sheet. And Korean conning paper. And probably dictionary too, because the problems will be asked in English. This is supposed to be English class, so you are supposed to answer in English, but you can actually write down in Korean too. So if you're fluent in Korean, you can write down in Korean. But I encourage you to answer all the questions in English. So any questions about grade policy? Yes.
Is the textbook allowed at final exam or quizzes?
No textbook. I mean, just coding and cheating sheet. Actually, there is no textbook for this class. I mean, you can just consult with the other engineering textbook or advanced calculus or whatever, but usually the lecture note will be good enough. And the previous lecture exams will be posted at the university site, right? Can you write down the previous? 알겠어? 옛날 썸도 있지.
옛날 썸 제가 올릴 거니까.
오케이.
근데 그 사이트가 그냥 포탈 통해 가지고 들어가는 거라서.
Alright. So there is an online lecture room. You can access to the portal site. Then there will be the past quiz, exams, etc., etc. And previous lectures can be found in YouTube. So my ID is Professor David An. Is my ID. And you search for Professor David An and math, then I don't know, almost 50 lectures, maybe more than 50 lectures are posted. So most of the lectures are in English, some are in Korean, so I mean, depending on. And so each year the lectures are slightly different. So if you like the lecture, maybe you can mark 좋아요 and 구독. Just kidding. And after the class, I usually put my class on the YouTube, so you can check. Also, I also post the PDF file as well. So if you just review the lectures through PDF files and review the lectures through the YouTube, then probably you wouldn't need the textbook. But these days, textbooks are quite expensive, isn't it? So. Am I talking too fast or too slow? Is it understandable? It's okay? You can follow my... So, if you think I'm going too fast, there's a very good way. Raise a question, ask me a question that can slow down the lecture. You can ask me a question, and desirably in English, but you can also ask me in Korean too. So, so you don't have to be brave to ask a question. So if you think I'm going too fast, just stop it and ask a question. That's one good way. Any questions? How many of you have taken my previous class? Raise your hand. One, okay. Also, how many of you have not taken calculus class? 미적분 안 들은 사람? No? So can I assume that everybody at least knows how to differentiate and integrate, right? That's very good. So during the first class, I usually talk about the history, how the mathematics was invented. So, how many years do you think that we have known mathematics in our history, throughout our history, or our mankind, known mathematics? Or number, simplified number. How many years do you think we have known?
Well, you have Pythagoras in the Roman Empire, so like a good couple centuries.
Couple centuries. Okay. That's a good answer, but actually you can go further back. In ancient times, before the beginning of the agriculture, our ancestors usually lived in the cave, called cavemen, right? So in the cave, our ancestors lived. They are usually hunters. They hunt rabbit. Or some of our ancestors lived by the sea or river. Some others, they catch fish, right? The caveman has been eating rabbit for many centuries and get bored, right? If you keep eating McDonald's all the time, every day, you get bored, right? Sometimes you like to eat fish. On the other hand, the fisherman has been fish all his life and have been eating fish all the time. So they get bored too, right? So accidentally, the hunters and fishermen met, and they agreed to exchange rabbit and fish. The simplest exchange ratio is what? One rabbit for one fish, right? The problem is how to count. How they count? Simplest way? Use fingers, right? So how many fingers normally we have? 10, right? So one fish for one rabbit, you use one finger count. What happens if there is more than 10 fish or 10 rabbits? What do you do? Bring your friends, right? So you can count up to 20. If it's really a lot of fish, maybe you can bring 10 people. It's up to 100. So that's the beginning of a number system base 10. It's simple, right? Because we have 10 fingers. Of course, some people have 6 fingers, but that's a more likely exception. So number system, base 10 number system has been begun. Maybe 100,000 BP. They didn't write it in the numeric form, like a Roman era or something, but they knew the numbers. It's called natural numbers. One, two, three, etc., etc. So natural numbers has been known for us probably maybe 100,000 years. And it's base 10. So base 10 is the result of the genetic inheritance. What if the dinosaur didn't extinct 65 million years ago? they evolved into intelligent being. So if it's a big if, but if dinosaurs survive and they become intelligent, and they're teaching mathematics like us, what kind of number system they will be using? Dinosaurs will be using base 6, right? If they have 3 fingers. So dinosaurs might have used base 6 numbers. Babylonians used 64 base 64. That's very strange, and I don't know the reason why. So natural numbers form a set. Set called an N. If you add two natural numbers, what happens?
New natural number.
Okay, natural number, right? If you multiply two natural numbers, okay, natural number, right? 2 times 3 is 6 is natural number, right? How about subtraction? Three minus 2 is 1 is natural number, right? 2 minus 3, we don't know, right? If the only number system we have is natural numbers, then natural numbers are close to only for addition and multiplication, right? Addition and multiplication. And time flies. So we have been known using natural numbers for 100,000 years, but there is a new number system called integer. It's a natural number plus 0 plus negative of natural numbers. So we have 1, 2, 3, etc. 0, minus 1, 2, minus 3, etc. etc. We have to thank India for that. It's about 2,000 years ago. India. So those parts were discovered by India around 0 AD. Plus minus, I don't know how many. So Indian people were very good at mathematics, and they invented 0 and negative integers. So they actually basically invented natural numbers, integers. So integer is sometimes, most in mathematical knowledge is called Z, set of integers. So you can add two integers to form an integer, right? And you can multiply two integers to get a new integer. You can even subtract integers to get an integer, right? I think that part probably have learned in your elementary school. How about division?
Can or can.
Depending on the case, right? If you divide 2 by 3, it's not integer, right? So integer is close to 2. Addition, subtraction, and multiplication. Oh, my handwriting is not very good, not very readable, but I think you will get used to it. I hope. So integer is close to addition, subtraction, and multiplication, but not division. The first number system that is close to 2, addition, multiplication, subtraction, division is called rational number, ratio. It came from rational. Q, set of rational number. It actually came from ratio plus NA. So ratio is the ratio, right? Ratio is like A to B, proportional. NA make it adjective. It's called suffix. Make it adjective. Suffix is called 어미. 전미사. 접두사 is prefix, right? If you put something in front, it's called prefix. Suffix, prefix actually came from the Latin. About 30% of the English words came from Latin. Through French. So rational is a ratio plus suffix to make it adjective, 유리수. So Q is defined as N over M, and M belongs to Z. So rational number was actually discovered around 10th century to 5th century BC. So there is a Chinese mathematics book called 구장산수. Chinese. It's around 10th century BC. And Western Greek, the famous The Element, 5th century BC, is by Euclid. So those rational numbers were described around 5th century to 10th century BC. You can ask the question, why? Why did error that period? All of a sudden, why they need the rational number?
Natural not exists at integer.
Right. But rational numbers, why they need the rational numbers? Around this time, they started no rational numbers by that time, right? Why? Taxation. They need to know how to divide the land. So that time is actually coincident with the formation of ancient kingdoms. Central, like a federal or central government. And they need a tax, right, from the people. And in order to get tax, they need to know how many crops they produce, or the size of the land, etc., right? So, the basic purpose of the invention of rational number is to have the taxation, to collect the tax for king or kin. So, by the time they thought that rational number is everything, right? They have no invention. They claim that they know everything about the mathematics they need to know. Also, this is called the four basic arithmetic operation. Subtraction, multiplication, and division. It's called four basic arithmetic operations. Addition, subtraction, multiplication, and division is called four basic arithmetic operations. In Korean, it's called 사칙연산. And four basic arithmetic operation is very important. Why? You can define function. For example, sin x 1 minus 3 factorial. No. Right. 1 minus x minus x cubed 3 factorial plus 5 factorial x to the 5. So this is what? Sorry. Subtraction. This is called addition. This x cos x cos x, multiplication. This division, right? So, for basic arithmetic operation is a basic operation that is needed to define functions. So you can define the formula for text. You can easily calculate, right? So until maybe 3rd century BC, they thought rational numbers is everything they need to know until Pythagoras discovered the irrational numbers. 3 BC, 3rd century before present, Pythagoras discovered irrational numbers such as pi or square root of 2. So if you try to find the square root of 2 in terms of ratio of two numbers, then you cannot, right? If 2 is n over m, there are no n, m belong to q. So it's called irrational numbers. Irrational numbers. So rational number plus irrational number is called real number. And R. So Pythagoras was the one who first discovered that probably the most complete number system is real numbers. So there's about 2 or 3 centuries before present. These number systems are all one-dimensional, just one-dimensional system, right? But if there is a way to extend the numbers, like some different set, it's a arrangement of numbers in rectangular form or square form. That's 20th century, early 20th century, late 19th century to early 20th century. The new mathematical system was discovered called matrix. And matrix is defined to satisfy, so question is whether the matrix satisfies the 4 basic arithmetic operations, right? Question. Will M So can you define the 4 basic arithmetic operations using matrix or matrices? That's been a question. And it's called, the mathematics about the matrix is called the linear algebra. So linear algebra is actually the first topic of this semester. We are going to learn the linear algebra maybe a little over a month. So addition. So A, we have For simplicity, we are going to focus on just square matrix. And 2 by 2 for simplicity. Of course, you can do it n by n. So addition. So A subtraction addition is defined as following: A11 plus minus B11, A21 plus minus B21, A22 plus minus B22. So addition and subtraction is defined by this term by term. So for example, A 1, 2, 3, 4, 5, 6, 7, 8. Then A plus B is 1 plus 5 is 6, right? 2 plus 6 is 8. 3 plus 7 is 10. 4, 8 is 12. A minus B. 1 minus 5 is minus 4. 2 minus 6 is minus 4. Oh, it's a coincidence. Minus 4. I didn't intend to do that, but the subtraction you identify. Multiplication is defined a little bit more complicated. Am I going too fast? Okay, soon you are going to think that I'm going too fast, but probably not now. Okay, A cross B. Sometimes just A, B. It's defined as the following: A11, A12, A21, A22 times B11, B12, B21, B22. So defined as the following way: you multiply by term and add. Oops. So A11, B11 plus A12, B21. This is the first element. Second element, you multiply this and this. So you have A11, B12 plus A12, B22. So the third element, we have A21, B11 plus A22, B21. The last element, A21, B12, A22, B22. So let's just do some example. Again, say A 1, 2, 3, 4, B 5, 6, 7, 8. Then AB. Okay, let's do together. It's a simple example. 5, 6, 7, 8. So, first element. 1 times 5 plus 2 times 7. So 5 plus 14 is 19. Very good. Second element. 1 times 6 plus 2 times 8. 16 plus 6 is 22. third element. 3 times 5 is 15, plus 4 times 7 is 28. So 15 plus 28 is 43, right? Final element is a little bit more complicated. 3 times 6 is 18, right? 4 times 8, 32. So 18 plus 32, 50. Very good. In number systems, you can change the order, right? 2 times 3 is 6. 3 times 2 is 6, right? Let's see if the same thing happens to the matrices. B times A. Let's check. B, A. 5, 6, 7, 8. 1, 2, 3, 4. First element. 5 times 1 is 5, right? 6 times 3 is 18. 5 plus 18 is 23. Right? Well, you don't have to do it the rest. It's not the same, but you just practice. Let's do it. Okay, so second element. 5 times 2 is 10. 6 times 4 is 24. So 10 plus 24 is 34. Seven times 1 is 7. 8 times 3 is 24. So 7 plus 24 is 31. Last one. 7 times 2. Oops. Seven times 2 is 14. 8 times 4 is 32. 32 plus 14 is 46. So in general, AB is not BA. The mathematically is called non-commutative. The mathematically non-commutative, or more mathematically is called non-abelian. In general, if you want to create two square matrix, it's not you cannot change the order. The result can be different. It's called non-commutative, or more mathematical language called non-abelian. So far we have known that the set of square matrix, you can define addition, subtraction, and multiplication with cos, because the multiplication is ordering between them. Right? You have to set the order. 순서. Somebody probably said that sure the word right. So at least 3 operations can be defined. Addition, subtraction, and multiplication. How about division? If you can define the matrix division, then then we have four basic arithmetic operations for matrix, right? That means we can define matrix functions. So actually that is the area for the quantum computing. If you can divide, if you can devise the matrix division, then you can define matrix functions. Then you can actually get into the quantum computing area. Maybe you can take a break for a few minutes and get back to the division part. And so we have seen that as square matrix, you can add, subtract, and multiply. Can we divide? The division is actually same as 3 times 1 over 3, right? So this is called inverse. So if A is A11, A12, A21, A22, and if A11, A22, A12, A21 is non-zero, we can define new matrix P as A11, A22 minus A12, A21 times A22, A11 minus A12 minus A21. Let's define a new matrix and see what happens. So AB, A11, A22 minus A12, A21 times A11, A12, A21, A22 times A22 minus A12 minus A21, A11 is 1 over A11, A22 minus A12, A21 times this and this, A11, A22 minus A12, A21, right? How about this? A11 minus A12 plus A12, A11, which is 0, right? So this is 0. And this A21, A22 minus A22, A21, which is again 0, right? Very neat. The last one, minus A21, A12 plus A11, A22. So it becomes A11, A22 minus A12, A21 times A11, A22, A12, A22 times 1001, right? So this cancels each other as long as A11, A22 minus A1 to A21 is non-zero. It becomes 1001, which is defined as identity. So if you multiply two matrices and then you get identity, then one of the matrices is the inverse of the other one. It's the same as defining division. Okay? So by defining inverse, you can define the division of the matrix. So in this way, we can make this particular matrix set as close to the four basic arithmetic operations. Then you are free to define the matrix functions. And let's check if this is commutative or non-commutative. What happens if you change the order? So from now on, slide. Define D as A inverse. A11, A22 minus A12, A21, A22 minus A12 minus A21, A11, right? So how do I discover this matrix? I will tell you later. But I happen to know that this is the inverse formula for 2 by 2 matrix. And there is actually, I can promise that we are going to discuss systematic way to describe the inverse matrix. How about if we change the order? So we found that A inverse is identity, right? This previous. How about the difference, opposite order? A inverse A. Let's check. A11, A22 minus A12, A21 over 1 times A22 minus A12 minus A21, A11 times A11, A12, A21, A22. I think this part probably I just progress a bit more slowly. So first element, as before, right? A11, A22, A11 minus A12, A21. How about second element? Second element, A22 times A12 minus A12 times A22, which is 1, 2, 3, 0 or vanish. So A22, A12 minus A12, A22. This part goes to 0, right? How about the other one? That is I'm doing intentionally to slow down. Minus A21 times A11 plus A11 times A21, okay, 0. This part, again 0. final part. Minus A21, A12 더하기 plus A11, A22. So these are the same factor, right? So you can put it out. A11, A22 minus A12, A21, A11, A22 minus A12, A21, 1001. So this cancels each other and becomes 1001. So we found one very important reason. The inverse matrix, the multiplication is commutative. Even though in general the matrix multiplication is not commutative, it's depending on the order, but one exception, the multiplication of inverse matrix is always commutative. A inverse A is identity. Commutative. There's one particular condition that in order to the inverse matrix exists, there is one condition, right? A11, A22 minus A12, A21 should not be 0, right? One more. So this is called nominator. In Korean, it's called 분자. This is called denominator or 분모. So, condition for the existence of inverse matrix is A11, A22, A12, A21 is not 0. And it has a name, determinant of A, or sometimes like this way. So if A is given by A11, A12, A21, A22, determinant A is defined as A11, A22 minus A12, A21. And I'm not going to prove that, but one important result is AB is determinant A times determinant B. If we multiply the matrix, then determinant of the combined matrix is the multiplication of each to the corresponding determinants. So actually, we can prove that for 2 by 2. It's not very difficult. So maybe I'll do that. If I proceed, for 2 by 2 is very easy. 3 by 3 is very complicated, but let's just show that this relation holds for 2 by 2. And let's presume that you can generalize it, general matrix, n by n. You just need to be patient. Okay. Are you ready? Can I move on? Okay, A11, A12, A21, A22, B, P11, P12, P21, P22. Determinant A, A11, A22 minus A12, A21. Determinant B, P11, P22 minus P12, P21. What about AB? A11, A12, A21, A22, P11, P12, P21, P22. So we have to be patient. Follow the definition. A11, P11 plus A12, P21, right? This and this. A11, P12 plus A12, P22. You actually have to write down yourself. If you just follow by eye, it's very easy to get lost. So I'll try to progress as slowly as possible. So A21, P11 plus A22, P21. Final A21, P12 plus A22, P22. So according to the definition, determinant AB, okay, times A22, P12 plus A12, A21, A22, P22 minus this A11, P12, A12, P22, A21, P11, A22, P21. We have how many elements? 1, 2, 4, only 8 elements, right? All right. Okay. The first one. If we do this, A11, A2, is A21 already. Yes. A21, A21, P11, P12 plus A11, A22, P11, P22. Oh, this A12, A21, P. This is P21, right? P21, P12 plus now this, right? This. A12, A22, P21, P22. we're half through. And I hope I didn't make any mistake. Just hope. This A11, A21, P12, P11, A11, A22, P12, P21. This A12, A21, P11, P22, and this A12, A22, P22, P21. And we have 8 elements and hope that some just cancel each other, right? So let's see. P1 to P. It looks like this cancels each other, right? And others. P1, 1 to 8 to 2, B2 to B1. This, right? So we have 4 elements. But we don't have enough room. So what do we do? There's a trick. Copy. Delete. And next page. Paste. I can move this, right? Surviving terms. We have A11, A22, P11, P22, minus A11, A22, P12, P21, right? That is this part, these 2 terms. Plus A12, A21, P21, P12 minus A12, A21, P11, P22. So A11, A22, we can combine them together. P11, P22 minus P12, P21. Minus A12, A21, P11, P22 minus P12, P21. So it looks like these are the common factors, right? So we can combine them together. A11, A22 minus A12, A21 times P11, P22 minus P12, P21. Right? That's determinant A times determinant B. Exactement. Right? So we can see that determinant A, B, determinant A times determinant B. Even though the matrix multiplication is not commutative, it can be associated. So any questions? Not very difficult, right? You just need to be patient. If you're patient enough, then you can get the result. This is very important to result too. A, B, C, A, B, C. So A, B, B11, B12, B21, B22, C, C11, C12, C21, C22. How about ABC? AB, A21, A22, B11, B12, B21, B22, right? So, again, this is not very difficult, but also very easy to get wrong results. So, you need to be patient. Let's try to slowly as possible. So first thing, A11, B11 plus A12, A21, B2, B, B21, right? Second element, A11, B12 plus A12, B22. A21, B11 plus A22, B21. Finally, you A12, A21, B12 plus A22, B22. Now ABC. Oh, I hate to copy it again, so I'll do some trick. Oh. Paste. How come? Is it this? Paste, paste, paste. 3, but no. Let me see. How did I do that? Fancy. I can move to next page, but how did I do that? Paste, paste. Oh. Maybe just do it hand, okay. A11, B12 plus A12. Usually it's supposed to work, but how come? A21, B11 plus A22, B21, A21, B12, A22, B22 times C11, C12, C21, C22. Oh. So this and this, right? I think we need more space. So A11, B11, A12, B21, C11 plus A11, B12, A12, B22, C21. How about comparing just one element? And the other three is FOMO. All right? Because I don't have enough room. Or maybe I just... I think we have enough time. Because I don't have enough space, I'll just move it here. A11, B11, A12, B21, C11 plus A11, B12, A12, B22, C21. Second element, this and this. So A11, B11, A12, B21, C12 plus A11, B12, A12, B22, C22. All right. This and this. A21, B11, A22, B21, C11 plus A21, B12 plus A22, B22, C21. And I'm getting tired. A21, B11, A22, B21, C12 plus A21, B12, A22, B22, C22. Okay. So I have done this 4 elements, but let's just compare one first element, and then the rest 3 you do it home as a homework. So, okay. Copy. Paste. So let's just compare the first element. This one. That is A, B, C. First element, 1, 1 is A11, B11, C11 plus A12, B21, C11 plus A11, B12, C21 plus A12, B22, C21. Now, how about B times C first? That is B11, B12, B21, B22, C11, C12, C21, C22. Now, by now you should be able to do it probably automatically. B11, C11, B12, C21, this and this, B11, C12, B12, C22, this and this, B21, C11, B22, C21. Finally, B21, C12, B22, C22. If we multiply A, B, C, we have A11, A12, A21, A22, and this B11, C11 plus B12, C21, B11, C12 plus B12, C22, B21, C11, B22, C21, B21, C12, B22, C22. Let's just compare the first element. A, B, C, 1, 1 is this and this, right? So A11, A11, C11, B11, B12, C21 plus A12, B21, C11, B22, C21. This is A11, B11, C11 plus A11, B12, C21, A12, B21, C11, A12, B22, C21. So let's check. So this element is same as this, right? And this one is this. A12, B22, C11. This element is same as this. And this is same as this, right? So you can actually compare the other three components as well. So I just compared the first element and it's the same, but actually you should have a phase. The other three are the same actually. So A, B, C, A, B, C. So even though the matrix multiplication is not commutative, it's associated. Associative. Homework. Show the other three relations. So you can just do the same thing for the other three elements, right? And here, homework means home. You do it home, but don't give it to me. Right? Homework is just home. You just say you're home, but you don't have to show me. Because I don't want to check. Yes? 호모학은 집에서 그냥 해보라는 거예요. 낼 필요 없어요. Homework is for your own benefit. And I don't want to waste my time to check all the answers. Because if I want to check all the answers, we have 100 students. And if I have maybe 10 minutes for each paper, that's 1,000 minutes. That's almost 20 hours. Too much time for me. So when I say homework, then you just do it home. But you don't have to, you don't need to give it to me. The homework may be important because I may ask in the quiz. Another homework is determinant ABC, determinant A, determinant B, determinant C. Again, this is another homework. Any questions about matrix multiplication, inverse, and associativeness? There are important matrix operations called transpose. By T, A, AT transpose, A11, A21, A12, A22. You change the row into column. This is called row. This is called the column. So transpose is just you interchange column and row. The transpose, row, column. Prefix, trans. is actually from Latin. Trans means across. So trans-Atlantic. Across the Atlantic Ocean. Transcontinental. Trans-Pacific means across the Pacific Ocean. And transcontinental means across the continental. Transcontinental. Pose is pose, right? Trans is just across. Transpose. Pose is something like this, right? Transpose, change, across. So this is a good way to learn new word. Probably you can just look for Latin suffix or prefix, then you can enlarge your vocabulary. That's one way. So one very important property of transpose is, okay, can I move on or? You multiply the matrix and you take the transpose, you change the order. So very easy to check. Just for 2 by 2. So you must be quite familiar about this notation by now. A11, B11, A12, B21, A11, B12, A12, B22, A21, B11, A22, B21, A21, B12, A22, B22. The transpose of AB is this. B11, B11, A12, B21, A21, B11, A22, B21, A11, B12, A12, B22, A21, B12, A22, B22. On the other hand, transpose of B, transpose A is B11, B21, B12, B22, A11, A21, A12, A22. We multiply them together, what do we get? Let's check the first term. P1, A1, A11, B11 plus A12, B21, right? This two. A21, B11, this A21 plus A22, B21. And this two, we have A11, B12 plus A12, B22. Finally, A21, A21, B12, A22, B22, right? So if you compare with this, this agrees with this, right? And this term agrees with this. And this one, same as this. Finally, this, same as this. So we have a very interesting thing, result. Therefore, if you multiply two matrices and take a transpose, it's the same as the multiplication of a transposed matrix in reverse order. BT, AT. So this property will be used. It's a very important result. So today is probably the first class. Maybe can I stop here? A bit slowly. So I'm going to stop today. And unfortunately, next week, I have to go to some important meeting, so there is no class. In Korean, 다음 주는 휴강. Any questions? 편성 못한 사람들은 내일 열어준대요. 친구들 중에 편성 못한 사람, tomorrow there will be opening in class for this class. So if you have a friend, please register. Tomorrow